Hi, it's Moser with a little hint and tip on number 15, the very last one on the 4B worksheet that's associated with your Holt Physics textbook. So we've got a hot air balloon with some ridiculous amount of mass being pulled down by a crew who is tugging harder than they really should have to on a rope. We're given the force of tension in the rope, we're given the angle at which the force of tension is being applied, and we obviously can figure out the force of gravity on the balloon. However, there's a buoyant force, that's an upward force that lifts the balloon, and we've got wind blowing from behind the crew, so that's working against them. We want to know the net force, net acceleration, and we'll get to part C in a second. So I've drawn a fun little balloon here, but that really doesn't help us because what we need is something more like that. So we've got a free body diagram showing all the forces and approximating the object as a square. And for part A, this is just a net force problem. So we find sum of forces on the x-axis, force of the pullers or force of tension on the x, minus the force of the wind because they're in opposition, and the sum of forces on the y-axis, buoyant force minus force of gravity and force of the pullers on the y. Well, once we do that, we've got two legs of a triangle, so it's down to Pythagoras. Don't forget, you've not only got to find your net force, you also have to find theta. That's going to become really important in just a minute. So for part B, we're asked for the net acceleration, and this is simple three-part algebra. I think you can manage that on your own. Don't forget that that net acceleration also has to have a direction. So you'll need to use theta that you found in the last problem, along with some sort of designation like below the horizon or above the horizontal or, counterclockwise from the who's it, one of those. Now, part C is the one that gives everybody fits, and people turn to their note card and they look at kinematics equations and they make it very complicated. But let me suggest that if you knew delta y and you knew theta, there might be a simpler, even trigonometric way to find delta x. Have a good night.